Hi, welcome to Marker Board Videos. Today's video is about ways to identify arithmetic and geometric sequences, and I think you're going to be amazed at how easy it is. So let's go ahead and get started. The first thing you need to do when you're identifying whether something is an arithmetic or a geometric sequence is to look at adjacent numbers. Now remember, adjacent means next to. So we're looking at numbers that are next to each other. They don't have to be the first numbers or the last numbers. They just need to be next to each other. Like 1 and 9 are next to each other. 81 and 729 are next to each other. 9 and 81 are next to each other. And in order to determine whether it's an arithmetic or a geometric sequence, what you're going to do is you're simply going to look at these two numbers and take the difference. So 9 minus 1 is 8. And then you're going to do the same thing here. 81 minus 9 is 72. So those are different numbers. If the difference is the same, then you know it's an arithmetic sequence. If the differences are not the same, you have to try something else. So to determine if something is a geometric sequence, you take the second number divided by the first number. That ratio, 9 to 1, is 9. The second number is 81 to 9. 81 divided by 9 is 9. Because those two ratios are the same, this is a geometric sequence. Let's try one more. 729 divided by 81. 729 divided by 81 is 9. So this sequence is a geometric sequence. Let's try another. 150, 133, 116, 99. So the difference between 150 and 133 is 17. 150 minus 133 is 17. The difference between 33 and 116, 133 minus 116 is 17. And 116 minus 99 is 17. Because that number is the same every time, that tells you this is an arithmetic sequence. Sometimes you're given word problems and they say, on Sunday Joe sold 1 car, and on Monday he sold 4 cars, and on Tuesday he sold 9 cars, and on Wednesday he sold 16 cars. And the question is that an arithmetic sequence or a geometric sequence? You're going to do the exact same thing. Adjacent numbers, so two numbers next to each other. 4 minus 1 is 3. 9 minus 4 is 5. So right away I know it's not arithmetic. Now I have to see if it's geometric. It could be both or it could be neither, but it's definitely not both and it's definitely not arithmetic. So let's do this. Second number divided by first number. 4 divided by 1 is 4. 9 divided by 4 is 2.5. That's definitely not 1. So this sequence is neither geometric nor arithmetic. It's neither. Let's try another one. 2, negative 8, 32, negative 128. And I can tell by looking at these, since these are not increasing or decreasing numbers, that the difference between two adjacent numbers is not going to be the same thing. So this is not an arithmetic sequence. Let's see if it's geometric. So let's try 32 and negative 8. 32 divided by negative 8 is negative 4. That's one of our ratios. Let's try another one. Let's try negative 8 and 2. Negative 8 divided by 2 is negative 4. That's the same ratio, so I'm thinking it's probably geometric. Let's make triple sure. Negative 128 divided by 32 is negative 4. And that tells me this is a geometric sequence. So let's do a few more. Let's say we're planting corn and we're going to tell the number of plants in each row. And I've got 4 rows. I've got row 1, row 2, row 3, and row 4. And in row 1 I plant 50 plants. And in row 2 I plant 60. And in row 3 I plant 70. And in row 4 I plant 80. If I'm given a word problem, I want to take it apart and get just the number so that I know what I'm doing. So the question is this a geometric sequence or an arithmetic sequence? 60 minus 50 is 10. 70 minus 60 is 10. 80 minus 70 is 10. So this is an arithmetic sequence. This number, the 10, is later going to be referred to as D. So keep that in mind. I think of D like difference. It's the difference between two numbers. But keep that in mind, because in a future video you're going to need to know that. You're going to need to know D, and now you'll know what it is. Let's try another one. We're going to put dots in a row, and we're going to have 4 rows again. 1, 2, 3, and 4. And in row 1 I put 15 dots. And in row 2 I put 45 dots. And in row 3 I put 135 dots. And in the last row I put 405 dots. And hopefully you can tell by looking at that the difference here is 30 and the difference here is way more than 30. So it's not going to be arithmetic. Let's see if it's geometric. 45 divided by 15 is 3. 135 divided by 45 is 3. 405 divided by 135 is 3. Remember, we're taking adjacent numbers. Since these ratios are all the same, this is a geometric sequence, and this number is called R. Again, you don't need to know that in order to identify whether something is arithmetic or geometric, but you will need that in a future video, so you might as well just get used to it now. Let's say I'm making some cupcakes and I'm going to put them on 4 different trays. And I'm going to count how many cupcakes can fit on each tray. On tray 1 I fit 166 cupcakes. On tray 2 I fit 166 cupcakes. On tray 3 I fit 166 cupcakes. And on tray 4 I fit 166 cupcakes. Well, you'll notice the difference between each of these is 0, which makes this an arithmetic sequence. And you'll notice the ratio of adjacent numbers, 166 divided by 166, the ratio is always 1. So this is an example of one that's both arithmetic and geometric. Let's do 2 more examples. 196, 225, 256, and 289. Well, let's see. The difference between 196 and 225 is 29. The difference between 225 and 256, well, let's see, 225 to get to 250 would be 25, and then to get to 6 would make this 31. 256 and 289, 256, 76, 86 would be 30. This is 33. Now you may see that the difference keeps going up by 2, but the difference is not the same each time. And if the difference is not the same each time, it is not arithmetic sequence. The ratios also are not the same every time, so this is not geometric either. So it is neither an arithmetic nor a geometric sequence. And let's do one last one. 1, 14, 27, and 40. The difference between 1 and 14 is 13. The difference between 14 and 27 is 13. The difference between 27 and 40 is 13. So this is an arithmetic sequence. I think of it like A for add. And this number right here, the 13, is called D. We're going to say it's the difference. And you'll need to use that for future work. I hope you now have a very good understanding of the difference between arithmetic and geometric sequences. If you have any questions, please let me know. Thanks.